and we're almost there. So this is the last part of the exponential and logarithmic functions video. Again, keep your calculator out because you'll probably need it. So here's the last page of the lesson. So below is some data on changes in life expectancy of Americans over time. So see year 1900, that's a life expectancy in years back in the year 1900. Year 2010 in the US, notice it rose quite a lot, 47.3 up to 78.7. So unbelievably, from the 1900s up to 2010, the average life expectancy in years, doesn't specify male or female, went from 47.3 up to 78.7. So if it was a table, it would be kind of going along like this, and then the next set of data is here. So our X data, would you agree, is like the year? X data is a year, and our Y data is a life expectancy. And then they mention, it's just rather than kind of make it a long skinny table, it's kind of like just broken up into two parts. 1900, 1910, 20, 30, 40, 50, 60, 70, 80, 90, 2000, 2010. It says plot the data on the graph below. Let one mark on the x-axis represent 10 years. So see like that? So for example, this would be the year 1900. Then 1910, 1920, 30, 40, 50, 60, 70, 80, 90, 2000, 2010, I think. I hope. Yep. Anyway, let's just assume that. Okay, so then, and notice, so we'll kind of have to label everything. So life expectancy in years, I'm having trouble because I'm not on an actual smart board now. So life expectancy in years is our Y data. So you should kind of like handwrite yours, and it goes on the Y-axis. Life expectancy in years is our Y data. There you go. So label your Y-axis, and down the bottom, like notice it's going 1, 2, 3, 4. So we could instead, what could we call it? Let's see. I need to make it a bit smaller. 17 point, 16 point maybe. And I'll make it orange. Time. Lots of 10 years, for example. Time. Lots of 10 years, starting with 1900. So that's kind of, you know, just trying to describe what's going on in the x-axis, like 1900. Maybe 1900 could almost be there, but I'll do it here. 1900, 1910, 1920, 1930, 40, 50, 60, 70, 80, 90, 2000, 2010. Cool. So we're going to go all the way up to 2010. So I'm just to keep myself on track, it's going to be about 2010 here. Just so I know I'm on the right track. So now we're going to plot the data. The first point, 1900, is at 47.3. So I've said 1900's here at point 1, 47.3. It's going up 40, 45, 47.3, could be about halfway, about there. 47.3. Feel free to pause and do it yourself and just check it at the end. Does it look roughly like mine? 1910, 50.0. 1910's about here. 50.0. Again, it's a bit hard for me to be accurate, so hopefully yours is better. 20, 54.1. 1920's here. 54.1 would be sort of a bit higher, pretty close to 55, just a bit below. What do we got here? 1930, 59.7. 59.7 is kind of a bit more level, pretty close to 60, isn't it? 59.7. And then we've got 62.9. Is that right? 1940, 62.9. 62.9, that's just gone up a little bit. Maybe it's a bit higher actually. I'm going to change that. 62.9, it's probably more like about here. Next one, 1950, 68.2. 50, 68.2. 65, 68.2 is going to be kind of maybe up like this. 68.2, and then 1960, 69.7. That'd be pretty close to 70. 69.7. 1970, 70.8. Not much higher, just a little bit higher. 1980, 73.7. Maybe up like this. And where were we up to? So we just did 73.7. 75.4 for the next one. 75.4, just a little bit higher. Should be a bit more like that. Actually, to be honest, that one's maybe a little bit low. So maybe like 73.7, that should be a bit higher. And then the next one, 76.8. 76.8, kind of probably about here. Being roughly now. 2010, 78.7. 2010's here. 78.7, maybe something like that. Basically, it's meant to kind of look like this at the end. So hopefully your graph kind of looks roughly like that. Fingers crossed. And then, so see, mine kind of looks similar. Awesome. So that is kind of the general graph. Plot the data on the graph and that kind of thing. We've done that. We've labeled everything reasonably well. That looks a bit small now, so I'm going to make that bigger. But yeah, don't forget to label yours. What kind of model fits the data? So would you say, let's see, it's not really exponential, would be kind of going up and then kind of going up more rapidly towards the end. Would you agree it's kind of going up reasonably rapidly and then it's kind of flattening out a bit? So that's kind of interesting, probably with advances in medicine, nutrition, lack of wars and all that kind of business. That's probably why life expectancy was so low and then rose dramatically. But then as kind of like, you know, you sort of hit the 60s and stuff, like a lot of improvements in medicine had happened, no real big wars or outbreaks of disease. So that's probably why life expectancy still continued to improve a bit, but wasn't improving as rapidly because it had already become so good. So would you agree that it's more like a logarithmic model? So I'd say logarithmic, that's what I would say, if you agree with me. Logarithmic, as it increases rapidly at first and then begins to level out, flatten out a bit. Change the color. Okay, so logarithmic as it increases rapidly at first and then begins to level out. Hopefully you agree, judging on what we've got here. So kind of increasing and then kind of leveling out a bit there. Next thingy, use technology to come up with a model for this data. So the fact that it's logarithmic means we're going to do a logarithmic regression. So I'm going to say enter the data on a spreadsheet on the TI Inspire, and then go menu, statistics, stat calculations. Then we're going to go logarithmic regression. So they're the kind of things we're putting into the calculator, if you aren't sure. So they're the things. I'll make that a different color. Let's make it purple. They're the things that will go into the calculator, and now we're going to find our model. So to enter this all into the calculator, great. As soon as it does that, you need to see what's going on here. So remember, we're calling 1900 1, we're calling 1910 2, we're calling 1933, and so on. So when we enter that into our calculator, we'll need to bear that in mind. So here's our calculator on the spreadsheet. So open up a spreadsheet. And what's our lovely data? 1900. So it goes up to, as you can see from the graph, it's going up to about 12. So we'll go, our X data will go up to 12. So feel free to pause and put this in if you want. It's taking a while for me to do it. It's easy to type in the wrong thing, so just double check that you're typing in the right thing. Then as you're scrolling up, you probably want to check, have you got the right numbers in there? Double check that. Now be really careful entering in this data, 47.3, so we need it all to match up correctly. 50, 54.1, 59.7, 62.9. Make sure to be doing this on your calculator too. 68.2, 69.7, 70, 73.7, 75.4, 76.8, 78.7, 78.7, 76. Did I miss something there? Let's see. I think I missed it. 76.8. So see, it's really worth going up over it again like this, isn't it? Because you can by accident not type in a number. There you go. 78.7, 76.8, 75.4, 73.7, 70.8, 69.7, 63. Yep, 68.2. That's right. 62.9, 59.7, 54.1. 50, 47.3, yeah, cool. So probably a good idea also to label what is going on up here. This is, we can call this one the year if you want. Y-E-A-R, like roughly year, lots of 10 years, whatever. And then this is called life expectancy, so maybe let's just call it life. You've got time, type more in. And we're doing this thing now where we go menu, statistics, stat calculations, logarithmic regression. X data here, Y data here. So menu, statistics, stat calculations. So see, you can't see logarithmic regression, but if you just hover down here, you'll see all these other ones. There it is. Underneath exponential regression, there's logarithmic regression. Our X list is the year. Our Y list is the life expectancy. Okie dokie. There it is. So generally, seeing down here, they're saying the general equation, a plus b ln x. They're doing the thing called the natural log. A little bit confusing, I'm sorry. And then so the A is 45.5, B is 13.87, and so on. I'm just going to take a quick screenshot of this and then paste it in, so then it's just easier for me to write it in as a model. I don't need the R squared, so I'm just going to take this. It's going to be easy for me to write down the model down here if I have it next to me rather than have to have the calculator on again. Okay, what happened to the snip? Copy. Okay. Brilliant. So don't just do this, like what you should be doing is like writing it out properly. So we've got the well, we'll call it x and y, so I'll just call it x and y. So we can go y equals life expectancy equals A, which is 42.5 to 3 sig figs, 42.5 plus B, and B is 13.9 to 3 sig figs, 13.9. Don't forget you've got the other stuff too, ln x. So ln just means a natural log base with a base e. Cool. That's our little model. Nice. And then you're asked to, here you go, use your model. It says use your model, not your graph, to predict life expectancies of Americans in 2030. So in that case, it'll be year, let's see, will it be year 13? Let's have a look at our graph in our table. 2010 is year 12, so this one's 2020, so 14 will be 2030. So we need to plug in 14 in for our x. So 14 is going to go in for x. So you can go y equals, I'm just going to be lazy, it's not on the board, so I'm just going to grab this stuff to begin with. Plug it down here. So we're going to start to use a model. And for x, I plug in 14. Natural log of, you can put a bracket around it if you want, looks terrible. Natural log of 14. You can just write ln 14, you don't need the bracket. It doesn't mean ln times 14, it means the log of 14. How would you plug that into a little calculator? Let's have a look. Here's our cute little calculator. So let's go on calculate. Cool. So 42.5 plus 13.9. I got those numbers right. Let's look. Yep, 13.9, 42.5. Yep, good. ln. Where's ln on the calculator? See ln? That's a natural log. Control ln. It's just a log with the base, and the base is e. The other log, normal log, common log, is base 10. Natural log of 14. Let's see what kind of life expectancy for 2030. Ooh, 79.18 or 79.2. So I'd write out the unrounded answer first. So equals 79 point, what was it, 18. Write it out to a few sig figs and everything first. 2, 8, and so on. Dot, 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 dot. Then do 3 sig figs. Equals 79.2 years. Let's have a look at our graph. Does that make sense? This is a way I can critically analyze my answer to see if I've done something wrong somewhere. Sorry, I'm trying to do this. I'm trying to write using the laptop instead of the board. So that's why it's a bit messed up. 79.2 years. Let's look. Doesn't make sense. Let's see, it's increasing. 75.4, 76.8, 78.7, 79.2. Let's see. 79.2 means that if 14 would be out about here, 79.2 would be about here. Kind of makes sense, doesn't it, in terms of the model? So it seems to be generally following the trend, so I'd assume that I probably haven't made a mistake. Looks like an earring on the queen. There you go, so that's how we can use our models. So that's what all these models are actually used for. So you can see how this might be kind of helpful to a health insurance company or something like that, because maybe they kind of need to work out, okay, in terms of working out what premiums we need to charge as a health insurance company to our clients, our customers, we need to know what the life expectancy would be in about 13 years' time, which would be the year 2030. So these models and graphs, they kind of pick up on general trends. And assuming that it was to continue this trend, we would assume it would be kind of at about 79.2. Remember that you never know what could come up. There's all sorts of strange things can come up. Financial crises and all that kind of thing. Unexpected stock market crashes could cause stress and sickness. There might be an outbreak of something, some natural disaster. could change life expectancy, you never know. So we don't know what's coming up in the future, but we can kind of have a general guess according to trends. So that's an interesting thing. Strange things in life and nature and everything can follow these weird mathematical trends. So that's the whole point of modelling, is you can plot some data, try to decide what kind of a model might fit that kind of data, then make that model, do a regression, make that model, and use that model to make predictions for the future. Pretty cool.